Okay, we'll start with final exam review 1. So in problem 1, we're given a set of data on the number of naps taken per week. And in problem 1, we want to know the sample mean. So you have a couple of options in calculating sample mean. The first one is to just add the numbers together and divide by the total numbers you have, which is 8. And when we add those numbers together, we get 14 over 8, which is going to give us 1.75. Our second option is to insert the data as a list and use that to calculate our one variable stats. So kind of as a refresher on how to do that, you're going to hit stat and then edit to get your list. Then you go back to stat, then you go over to calc, and then you want to use one variable stat. And you got to make sure that you're drawing from the list that you entered your data in, which I entered from list 1. And that the very first thing it gives us, X bar, is the mean. If we're using this as well, it's easier to calculate sample variance and standard deviation. Remember, the sample standard deviation is SX, which is 1.669. The sample variance is just the square of the standard deviation. So if we do 1.669 and we square it, we're going to end up with 2.786. Again, with calculating the median, you have options. You can either do it by hand, so cross off the data from one end to the next, working your way in order. And then because we have an even number of data, we have 2 remaining and we have to find the mean of those. So the mean of 1 and 2 is going to be 1.5. So our median is 1.5. Again, if you go to one variable stats and you scroll down a little bit, it does give you the median as well, abbreviated MED. The last thing we want to do is determine if any of the data points are outliers. And the way we're going to justify our answer here is with work. So we want to use the 1.5 IQR rule to find any outliers. So remember, the IQR is the interquartile range, and the way we find that is doing quartile 3 minus quartile 1. Again, if you're in the one variable stats for this data, it gives you quartile 1 and quartile 3. Quartile 3 is 2.5 minus quartile 1, which is 0.5, which gives us as our IQR is 2. So to calculate any outliers, the first way is to take quartile 1 and subtract 1.5 times the IQR. And the second way is to take quartile 3 and add 1.5 times the IQR. So for our first possible outlier, quartile 1, we're going to do 0.5 minus 1.5 times 2. Which is going to give us negative 2.5. And for our second possible outlier, we're going to take quartile 3, which is 2.5, and add 1.5 times 2. Which gives us 5.5. Since none of our values in our data set is below our quartile 1 value after we use the 1.5 IQR rule, or above the quartile 3 after using the 1.5 IQR rule, there are no outliers. So our next piece of data is records the weight of a car in thousands of pounds and its gas mileage, and we want to answer the following questions. So the first one is, what can be said about the strength of the relationship between the two variables? So in order to determine the strength, you want to find R, which is the correlation coefficient. In order to calculate the correlation coefficient, we're going to go back into our lists and we're going to enter the weight into list 1 as our X value and the gas mileage as our Y value into list 2. Once you have your lists, you're going to go back into stat, then over to calc. And in order to calculate correlation coefficient, we want to do the line of regression, which we're going to use 4. So we want to make sure that our X list is drawing from L1 and our Y list is drawing from L2. Then we're going to hit calculate. Then we're going to look for R, and R is negative 0.818. So the strength of the relationship is based on how close to 1 or negative 1 your R value is. And because 0.818 is close to 1, it's going to be strong. And then the direction is based off its sign. And because it's negative, it's going to be strong and negative. Now we want to write the equation for the regression line. So since we're in that same window, we're going to do y equals, our slope is going to be a, so negative 7.353x plus b, which is our y-intercept, 46.066. We can now use this equation to find an expected value. So we want to know what we expect the gas mileage to be on a car weighing 2,050 pounds. So remember, the weight is X, the mileage is Y. It's important here to remember that our weight is in thousands of pounds. So I'm actually, in order to plug in for X, I have to take 2,050 and divide by 1,000 first. So I'm actually going to be plugging in 2.05 in for X. So to calculate my gas mileage, we're going to do y equals negative 7.353 times 2.05 plus 46.066. So once we plug that into a calculator, we're going to get our weight is 30.9, our gas mileage is 30.99, or about 31. Next, we're going to go over the difference between an observational study and an experiment. So remember, in an observational study, we observe and we do not influence responses. Whereas in an experiment, we impose a treatment. And we measure the responses from that. Next, let's go over some probability. So the first question is, what are the basic rules of probability? So it means the probability of some event A occurring is the number of outcomes possible over the total number of outcomes. So for example, if I'm rolling a die and I know the probability of rolling a 2, probability of A, there would be 1, 2 over a 6 total number of outcomes. Next, we're going to go over the addition and multiplication rules. So the multiplication rule, which is the probability of A and B occurring, is going to be the probability of A times the probability of B. The addition rule, so the probability of A or B, as long as they're independent, it can be the probability of A plus the probability of B. But if they're not independent, we then have to subtract the probability of A and B, which is where the probability of both occurring. So you have to first determine whether or not you have an independent event so that you know if you can just add the probabilities together or if you have to subtract their overlap. So 2 events can be considered independent if the probability of one event does not influence the probability of another event occurring. Number 7, if the probability of passing this exam is 0.8913, what is the probability of the complement of this occurring? So remember, all probabilities add to 1. The complement is the probability of something not occurring, which equals 1 minus the probability that it does. So all I have to do is 1 minus 0.8913, and we're going to get 0.1087. So we have a almost 11% chance of not passing the exam. Next, we have that if the probability of passing this exam is 0.8913, what is the probability that all 24 students in the class pass, and then what is the probability that at least one person will pass? So probability of all 24 students passing is going to be 0.8913 to the 24th. Because these are independent events and one person passing does not determine the probability of another person passing. So we're going to get 0.0632. The probability that at least one person will pass is 1 minus the probability that everyone passes. So 1 minus 0.8913 to the 24th. Which is 0.9368. So we have a probability experiment where 2 colored spinners are spun. Each spinner has equal chances of green, blue, yellow, red, and orange. We have the events A being spinning green on the first spinner, B spinning at least 1 blue, and C spinning exactly 1 yellow. So first we want to go for the sample space. So the sample space is actually going to be fairly large, and I'm not going to write out all of it. So I'm actually going to use abbreviations. So I can do green on the first spinner, green on the second, green on the first, blue on the second, green on the first, yellow, green, red, green, orange, and then you keep going through. So then you would do blue, and then green. You keep going through each color and all of the different possible outcomes, which should be a total of 25 different outcomes. Now we want to find each of our probabilities. So the probability of A, spinning green on the first spinner. So there are going to be 5 of our events from our first spinner that have green as the first one and out of 25 total, which is going to give us 1/5. The probability of B, which is spinning at least one blue. So if you go through all of your list of your events, you should get 9 of them being at least one of them blue out of 25. Our last probability, spinning exactly one yellow. So in each of our first spinners, there's only, like when I spin green on the first one, there's only one time where one of them is yellow. Same thing for blue. Now, when it comes to the yellow being the first one on the first spinner, all 5 of those first outcomes would have a yellow, except one of them would have 2 yellows. So I have to exclude one of them from where the first spinner is yellow, and then there's one exactly when the first spinner is orange. So that should give me a total of 8 out of 25. Okay. Next, we want to find the probability of A and B. So that's the probability of spinning green on the first spinner and spinning at least one blue. So the probability of A and B is the probability multiplying them together, so 1/5 times 9/25. You can multiply straight across, or you can use your calculator to multiply your fractions, but you should get 9 out of 125, which is about 0.072. Well, it's exactly 0.072. Next, we want to find the probability of B or C. So that's the probability of spinning at least one blue and exactly one yellow. So probability of B or C, the probability of spinning at least one blue is 9/25, plus the probability of spinning exactly one yellow is 8/25. And then we have to subtract the overlap, because there is the spin where you get at least one blue and exactly one yellow, which is 1 out of 25. So 9 plus 8 is 17, minus 1 is going to give us 16 out of 25, which is 0.64. Next, we want to know, are the events A and B mutually exclusive? So remember, mutually exclusive means that 2 events cannot happen at the same time. So in this case, we're asking, is it possible to spin a green on the first spinner and spin at least one blue? And the answer is yes, which means A and B are not mutually exclusive. The last question is, are the events A and B independent? So remember, independent means the probability of event A happening does not change the probability of event B happening. And because the probability of spinning a green on the first spinner does not determine the probability of spinning at least one blue, these are independent. These are all of the problems on the final exam review 1. Please let me know if you have any questions or if you think I've made a mistake. We all know sometimes it happens. Again, please make sure you ask for help if you need it.